The universe is full of surprises, and our galaxy's destiny just took a dramatic turn. For decades, scientists believed the Milky Way was on a collision course with Andromeda. Now, new research suggests that cosmic crash might not happen after all. For years, astronomers predicted a cataclysmic merger between the Milky Way and Andromeda galaxies, forming a new elliptical galaxy dubbed Milkomeda. This long-anticipated event has been featured in countless documentaries and textbooks as a cosmic certainty, unfolding in about 5 billion years. The concept was staggering. Two massive galaxies, each with hundreds of billions of stars, swirling into a gravitational dance and merging into one. However, a recent study published in Nature Astronomy on June 2, 2025 challenges this long-held belief. The authors reveal there may be only a 50% chance of such a collision occurring within the next 10 billion years. It's a staggering revision, one that calls into question how we forecast galactic fates. The study was spearheaded by astrophysicist Dr. Till Sawala from the University of Helsinki, whose team used advanced modeling based on extensive data from NASA's Hubble Space Telescope and the European Space Agency's Gaia satellite. Gaia, launched in 2013, has been mapping the Milky Way in unprecedented detail, tracking the movement of over 1 billion stars. This celestial census, when paired with Hubble's deep space observations, allowed for an extraordinarily refined model of the local group, the collection of more than 70 galaxies, including our own. Importantly, previous simulations often focused solely on the Milky Way and Andromeda, treating them as isolated dancers in a cosmic duet. But our local universe is far more crowded. The Triangulum Galaxy, or M33, and the Large Magellanic Cloud, a smaller satellite galaxy orbiting the Milky Way, also exert gravitational influence. By including these additional players, the team was able to more realistically simulate 100,000 potential future timelines, tracing the orbits and interactions of these galaxies over the next 10 billion years. These simulations weren't just rough sketches. They incorporated complex gravitational feedback, varying galactic masses, and historical motion data. Each model is like a crystal ball, but one with probabilities instead of certainties, painting the galaxy's future with more nuance than ever before. It's a step closer to precision cosmology, where predictions are built not just from theory, but from the rich, living data of the stars themselves. And while such simulations cannot tell us which exact scenario will come to pass, they offer something arguably more powerful, an evolving framework to anticipate the behaviors of galaxies like weather systems, shifting with the forces that shape them. The results upended expectations. Contrary to prior assumptions, the inclusion of the Large Magellanic Cloud, often considered a minor participant, actually reduced the likelihood of a merger between the Milky Way and Andromeda. This seemingly small galaxy, with only about 1/10 the mass of the Milky Way, acts as a kind of gravitational buffer, tugging subtly but significantly on the Milky Way and shifting its path. On the other hand, the Triangulum Galaxy was found to play the opposite role. Its influence increased the probability of a future galactic collision, effectively nudging Andromeda closer to our own galaxy over time. This delicate gravitational choreography reveals a stunning truth. Our galactic future is not predetermined but probabilistic. Dr. Sawala stated, "We find that if only M33 is added to the two-body system, the chance of a Milky Way-Andromeda merger actually increases, but the inclusion of the Large Magellanic Cloud reduces that probability." The fact that these minor galaxies can so drastically alter the fate of entire galactic systems is both humbling and thrilling. In some simulation outcomes, Andromeda slingshots past us in a near miss, altering both galaxies' paths forever without a full collision. In others, we merge slowly, our stars swirling into a chaotic but majestic reshaping of galactic identity. There's even a scenario where all three, Milky Way, Andromeda, and M33, collide in a drawn-out ballet of destruction and rebirth. In the most extreme outcomes, the galaxies tangle and then separate again, creating vast tidal tails of stars, streamers of light stretching across intergalactic space like spilled stardust. It's the kind of transformation that takes billions of years, but leaves a signature that lasts forever in the memory of the cosmos. Some of these encounters are slow-motion cataclysms, taking place over spans of time so vast that 1 million human civilizations could rise and fall in the interim and never even notice. The broader implications of this study are profound. Galactic collisions are key events in the universe, triggering bursts of star formation, black hole mergers, and the creation of new structures. If our Milky Way avoids merging with Andromeda, its future could look strikingly different than once imagined. Rather than coalescing into an elliptical galaxy, it might retain its spiral shape for far longer, preserving the cosmic architecture we call home. Additionally, this research underscores the importance of precision in cosmological forecasting. Astronomers now see that small factors, such as the orbit of a relatively tiny companion galaxy, can dramatically alter long-term predictions. Future missions, like the upcoming Nancy Grace Roman Space Telescope and the European Extremely Large Telescope, will provide even finer resolution on the movements and masses of nearby galaxies, improving our ability to peer into the deep future. This study is a compelling reminder that cosmic destiny is not written in stone, but inscribed in forces we are only beginning to understand. Each gravitational ripple, each orbital eccentricity could steer the path of a galaxy, and by extension, the context of civilizations within it. Even a slight miscalculation in a galaxy's velocity today could become a billion light-year difference tomorrow. Understanding these intergalactic dynamics also holds clues to the past. By running these simulations backward, astronomers can better reconstruct how the local group formed, offering glimpses into the Milky Way's ancestral migrations through space. Every collision, avoided or enacted, carries a hidden record of the universe's ancient choreography. And beyond the math and models lies a deeper question. How does a galaxy's journey through space shape the potential for life within it? The answer is written not just in stellar collisions, but in quiet corridors of space where worlds might remain undisturbed, evolving under peaceful skies. The fate of the Milky Way remains an open question, poised between a breathtaking celestial collision and a quiet cosmic sidestep. This study not only reshapes how we think about our galactic future, but reminds us that the cosmos is still writing its story. As galaxies drift across the fabric of space-time, the universe invites us to ask questions, not just about where we're going, but about how we're connected to the great dance of gravity, light, and time. Are we hurtling toward a grand embrace with our nearest neighbor, or will we circle each other forever in a slow spiral of cosmic tension? These are not just technical questions, they are human ones too. Because in understanding the fate of the Milky Way, we glimpse the fragile, ever-evolving context of our own existence. Let that be a reason to look up tonight into that luminous band across the sky and know that it too has a story still unfolding. Subscribe to our channel for more real, recent science discoveries, and stay curious, because the next surprise may be written in the stars.